Stanford University.
Welcome everyone to the very last lecture, lecture number 14 of Stanford CS 193P during spring quarter of 2020. For all of you, it's all final project all the rest of the way. However, I do want to talk about one last feature in SwiftUI, which is the integration with UIKit. Remember that UIKit is the old way of developing applications for iOS. And when SwiftUI came out a few months ago, it does pretty much everything that UIKit does, but there's a few UIKit features in there that aren't in SwiftUI, and you'd like to be able to use them. And so this API makes it really easy to do that. Also, you might be an existing developer of an iOS app and you've got a bunch of UIKit code, and of course you want to use that as you transition over to SwiftUI, and this lets you do that as well. Now, for me to talk about this feature, I have to explain a little bit about how UIKit works. I'm not going to teach you any UIKit itself, but conceptually, it's important to understand some basics about it. One thing is there's no MVVM in UIKit. Instead, it's something called MVC, Model View Controller. And in the Model View Controller architecture, views are kind of grouped together and controlled by something called a controller. This controller is sort of the granularity at which you present views on screen. And by presenting, I mean like SwiftUI's sheet or popover or the destination of a navigation link. Those are presenting views on screen. Well, in SwiftUI, there's no difference. We don't have any controllers. So views are just views and we present them whenever we want. It's quite nice. But in UIKit, it's different when you're putting views on screen. You have to essentially present a controller, and the controller controls views. Now, because of this, because you've got this controller thing, the integration between SwiftUI and UIKit really needs two integration points. Now, these two integration points are very similar, but one is a UI view representable. That's a SwiftUI view that represents a UIKit view. And then there's also UI view controller representable, a SwiftUI view that represents one of these controllers and all the views that that controller controls. You can see these things look the same, but it's just necessary to have both because of UIKit's underlying dichotomy between their views, like buttons and text view, those are views, and their view controllers, which are these groupings of views. Now, the main work that's involved in implementing either of these two representables is dealing with setting of the vars to configure the view or the view controller. And especially with the view controllers, they often want to call you back and say, this happened in my view controller and what should I do about it and things like that. I say here, quote, callback functions on the slide, but it's not really callback functions per se. And I'm going to dive into that a little bit more now so you can understand how this mechanism of a view is on screen or a view controllers on thing and things are happening, how do we interact with it, works in UIKit. And the main concept there that you need to understand is something called delegation. Remember, UIKit is object-oriented, not functional programming, it's object-oriented. So it's very different. It's not declarative, it's not reactive, none of those things. And it uses heavily a concept called delegation. We briefly mentioned this when we talked about File Manager. File Manager has a delegate, but these objects, these controllers and their views have a delegate that they literally delegate functionality to. Some of the functionalities, views and view controller, they offer to allow some other object to control that. Now they do this by having a var in themselves. The views or view controllers have a var in themselves called a delegate. And this delegate var, its type is some protocol. Now, we know protocols well, of course, as functional programmers. In object-oriented programming, protocols are used not as much, and the protocols are slightly different in that the methods and vars in the protocol, some of them can be optional. So not optional like the enum optional, but optional like you don't have to implement them. You're going to see when we do our demos today, we're going to do a couple of different delegate protocols, and we're only going to implement one or two methods in each one, even though there might be 10 or 15 methods available, you might not need to use all of them. This delegate var has this object, which can be pretty much anything as long as it implements this protocol. And this protocol has a lot of things in there like, I will do this, and I should I do this? And I just did do this. Those kinds of notifications are happening between the view or view controller and this delegate. So when we do our integration between SwiftUI and UIKit, we have to somehow provide this delegate so that this view or view controller can function, because a lot of times they need that delegate to do anything of any substance. So I decided in the two demos that I'm doing today, I'm going to do one view representable demo and one view controller representable. Both of them are going to have a delegate, so you can see how that integrates. So talk about these representables, these two SwiftUI views, UI view representable and UI view controller representable. They're super similar, and they both have these 5 main components. The first one is just a function that creates the underlying view or view controller. It's just called make UI view or make UI view controller. And you get past this context, which I'll talk about in a minute, and you just return the view or the view controller that this representable is basically representing with some SwiftUI view. So that's obvious, we need that. Another obvious thing we need is something to get this UIKit to participate in the reactive nature of SwiftUI, right? When a binding changes or observable object changes or some internal state changes, something like that, we do some intent in our changes our model or ripples back to us and we redraw in the UI, we are redrawing our views, updating them all the time in SwiftUI. This doesn't really exist in UIKit. So in your representable, you have to implement a function called update UI view or update UI view controller, and it will pass the view controller that you created with make UI view back to you, along again with this context, which I'll talk about in a second, and you now update that UI view. So this is getting called whenever your Swift UI view is part of an update pass, right? It's being updated, and so you have to be able to update the UIKit. And here where you might set vars, you might pass values, whatever in there. You can have binding. I mean, UI view representable and UI view controller representable, they are Swift UI views. Of course, they can have @sign bindings, and maybe you're getting some values out of these things that are bound back to your other Swift UI views, and you're setting it in your UIKit view. So that's what's happening here. Now, this third thing is a function called makeCoordinator that's going to return what's called a coordinator. Now that coordinator is a don't care. It can be anything you want, right? It has no requirements on it. I'm not even sure it has any constraints and gains on it. The main thing about this coordinator though is it's something that's going to be passed back to you via that context above. All right, so this coordinator is the thing that's going to serve as the delegate of our UI view or UI view controller if it needs one. And it's really nothing more than a collection of the functionality that you would need in a delegate to make your view or view controller work. Really, the whole UI view and UI view controller representable system doesn't even care what this thing is. It just wants to give you an opportunity to have some object that is being the delegate. Now, this context I keep talking about up here, this pass to the make UI view and update UI view, it has 3 things in it. One is the coordinator you created, the thing that's going to be the delegate for your view or view controller. It also includes your SwiftUI's environment, like are you in dark mode, all those things. And it contains a transaction. So this is an animation transaction. I told you earlier in the quarter, we're not really going to talk about transactions. But it's essentially encapsulating what sort of animation environment is going on while the make UI view or update UI view is happening. So that's what this context is. Mostly out of the context, you're going to be grabbing environment stuff, or you're going to get your coordinator so you can talk to the delegate, basically, of your view and view controller. I don't want to make it sound like your coordinator can only be the delegate, but that's its primary, probably the primary thing you use the coordinator for. And then finally, there is a teardown phase when your SwiftUI view is going away. Of course, you want to be able to clean up your view controller or your view, and it's just passed back to you along with your coordinator, your delegate, or whatever, so you could clean that up as well if you have to. You can do whatever's necessary there. That's it. Pretty much that. You make it, you update when the passes happen through. You've got a little coordinator you can have be your delegate, and then you can dismantle it when things are all done. So the demos I'm going to do today, the two demos, one, we're going to go back to Enroute, and in the filter flights, we choose the destination airport right now from a picker, and we're going to make it so we can choose that destination airport from a map, an actual map, Apple Maps-like thing right in our UI. We can pick the airport that way, and that's going to be essentially a UI view representable, because the map is just going to be a UIKit map called an MK map view. It's actually not even in UIKit, it's in something called MapKit, which is really part of the whole UIKit ecosystem. And then the second feature we're going to do is we're going to go into EmojiArt and make it so that the background image, instead of being dragged in or copied and paste, we're going to add another way to do it, which is you can take a picture with your camera or just get a photo out of your photo library and use that as the background. Now, this is going to use a UI view controller representable, because getting a picture from the camera involves putting up one of these MVC things, these controllers that controls all the views that are in the UI that gets a picture from the camera, and same thing with the photo library. So this is a little slightly different kind of integration, this view controller integration. Now, I'm just giving you a caveat before we start this demo. I'll probably mention it again in the demo itself. This is not an awesomely implemented feature for us in EmojiArt, because we take the picture from the camera or the photo library and we just drop it into our file system and store it as a URL in our EmojiArt like we've been doing so far. That's actually not really appropriate here. You would probably want to put the image itself, the actual JPEG or whatever image data, into your EmojiArt model, right? Store it there, so that if you took that EmojiArt document someday and you moved it to another device, it would actually work. Whereas the solution we have, where we just drop it in the file system and grab a URL to it, it's obviously pointing to something that's in the sandbox of this app. It's kind of, bogus. But we're not worried about that. We're not worried about the background. We're worried about how do we put the UIKit UI, the controller that gets images from the camera or the photo library, how do we get that to work in our SwiftUI so we can get the image out of it? So that's it. So let's dive right in. Enjoy the very last demo of the year. The first of the two demos here is going to be showing how to integrate a UIKit view into a SwiftUI view. And the UIKit view we're going to do is map view. Actually, it's in its own little framework called MapKit, but it is a UIKit style view. And what I essentially want to do is, here in my filter flights, where we're choosing our destination, origin, our airline, etc., for the destination, I'm still going to allow you to pick your destination via picker, but I also want you to be able to pick it via a map view that we create by using the UIKit map view. Let's put this in its own section here, and we'll put the other things in their own section. I could imagine that quite easily. Wanting to use this map also for the origin later, we're going to focus on just doing it for the destination for this demo. So what is this map view thing right here? It's going to be one of these UI view representables we talked about. Let's go create that. File, new file. It is a SwiftUI view, but since it's going to be a UI view representable, it's not going to have var body. That's going to be implemented by UI view representable for us. Let's go here. I'm going to call this my map view. And when we're doing our map view, we're going to have to import more than just SwiftUI. We're going to have to also import UIKit and also import MapKit. A lot of imports to do right there. This struct called MapView, it is a view, but it's even more than a view. It's a UI view representable. This is a different protocol right here that inherits from the view protocol, but it has a bunch of other stuff in it that allows us to do this integration with UIKit, obviously. And we see that we do not conform to the protocol UI view representable, because we have to put those functions that I was showing you in the slides, like func make UI view, given certain context. that returns the UIKit view that we want to do. And what are we doing here? We're doing MK map view. This is the UIKit view we're trying to build. And in fact, I'm going to build it here. Okay, map view equals MK map view, and return the MK map view. Be doing a little more to create it here in a second. And we also have that func update UI view, which gives us the UI view back, this MK map view, and also that context. And inside here, we can do whatever we need to do to keep this map view up to date as our SwiftUI goes through its normal reactive redrawing mechanisms. And then we have this func make coordinator, which returns something that is a don't care, which I'm going to call coordinator, this type right here. I'm going to make that a little nested class inside my struct here called coordinator. And it's going to be my map view's delegate. This map view has one of those things we were talking about, a delegate. So to be a delegate, it has to also be an NS object, and it has to implement the MK map view delegate protocol. All the delegates in UIKit always are classes that inherit from this base class NS object. So we need to do the same thing here in our SwiftUI compatibility as is done in normal UIKit. Make a delegate that inherits from NS object and implements these methods. Now, turns out none of the methods in here are required, but we're actually going to need a couple of them to make this work. But that's why I'm not getting any complaints here that this protocol is not implemented or something like that, because it has 10 or 12 methods, all of which are not required. So how are we going to make our coordinator? I'm just going to literally say, make me one of these coordinators that I just defined down here. This is just a class. I'm just making a class, and I'm returning it here. I don't have to say return, but that's what I'm doing. This is the basic structure of a UI view representable right here. The only thing is we want to hook up our coordinator, which is this delegate, to our map view. We're going to do that right here by saying MK map view, your delegate is our coordinator. And we get the coordinator out of our context. This is not where we create the coordinator. It gets created down here inside this. So if we want it, we just say context.coordinator. So let's go back to our filter flights. And if we build, actually, this succeeds. It's able to build because we made a thing called map view. This is a normal SwiftUI view called map view right here. And if we run, go to our filter, there it is. There's our map right there. Now, you can't see much. It's still too small. So why don't we make this a lot bigger? Maybe have it be, at least maybe 300 or 400 points high. The width is fine, but I want to make sure that it's at least 300 or 400 points high. So I'm going to go down here and say dot frame min height of 400. Let's see what that looks like. Filter. Whoa! That looks a lot better when you can see it. And there is our map. Now, of course, none of these airports that we have here are showing up on the map. There's no kind of markers or anything for it. That's because we don't do anything to put them on there. So let's learn a little bit about MapKit. How does one put little markings on here to represent these airports? Well, MapKit is actually pretty flexible and it uses protocols. It has a protocol called MK annotation, and any object that implements MK annotation can be put on a map. So all you need to do to put an object on the map is implement MK annotation for that object. So what kind of objects do we want on our map right here? Well, we want airports. So here's our airport. This is our core data object that does the airport. I'm just going to add an extension to it that implements this MK annotation protocol. And we need to import MapKit here because MK annotation is inside MapKit. Now, what is required of this MK annotation protocol? Let's go ahead and even use our fixit here. You can see that type airport does not confirm, but we can add protocol stubs that will add the required methods here. Fix. There it is, just this one var. If you implement just this one var, then you too can be an MK annotation. And what is this var coordinate? What's its type? What's it returning? It's a CL location coordinate 2D. This is latitude and longitude. And luckily, airports, if we look at our data model over here, especially the version here, you can see we have a latitude and longitude that we got from FlightAware. So we are absolutely ready over here to be one of these. I'm just going to return creating a CL location coordinate 2D from a latitude, which is our latitude. This is just a var in the database, and longitude. This is our other bar. That's it. Look, compiles, allows us to be an MK annotation. Now, MK annotation, again, it's a Objective-C version of a protocol. This is the only required var, but it has a couple other var that I'm going to throw in here. And one of these vars is called title. It's an optional string. And it's something that if you click on something in the map, it'll show you this title. So I'm going to have this be the name of the airport. If that's not set, we'll use the KSFO or whatever. And then it also has another one called subtitle, which it'll also show in the call out that comes if you click on something. And we'll put the location like San Jose, California or whatever in there. So airports are now MK annotations. And that means that they can be put anywhere on this map. If we drop an airport on this map, it's going to have some sort of little representation of it. And we'll show you how to do that in a second as well. We need to have our map view right here have some sort of var that you can pass into it. I'm going to make it a let even, which is the annotations. It's just an array of those MK annotation things. So this could be airport, okay? Anything else that implements MK annotation. And when we make our view, in addition to setting the delegate here, I'm going to add these annotations to the map. That's it. That's all we have to do to make them be on the map. Now, the only problem is the map has no idea how to draw them. It doesn't know, are you drawing some sort of pin or some sort of marker or custom view, or what are you doing to draw it? And how these annotations get drawn on the map is actually controlled by this delegate. So we're going to see our first ever delegate method from UIKit. And the one we want here is called map view for annotation. Let's see if we can find it. Look at all these. These are all map view delegate functions right here. Did select something, did deselect, the region we're showing on the map changed. I'm looking for the one which is view for annotation. It's right here. And this is just returning something called an MK annotation view, which is a UIKit view that shows annotations. And that all it's doing is getting the right one for a given annotation. In our case, these are airports, so just creating a view for the airports. Now, we're not here to learn MapKit, so I'm just going to show you how one does this to create this little view. And I'm going to use a pin. You can also do markers, which are kind of a new look of the map. You ask the map view to DQ a reusable annotation view with the identifier, and we can use any identifier we want here. I'm going to call my map view annotation. And if that comes back nil, I can't reuse one. This is reusing one of those pins or whatever. Then I'm going to create my own MK pin annotation view. That's the one that looks like a pin. And it takes the annotation, like our airport or whatever. And it also wants that reuse identifier again, the same thing here. Should probably create a constant for that, but just quickly type it in here. And that is creating a little pin annotation view. There's the newer one is called a marker annotation view. We could use that, but I'm going to use the pin. I kind of like the call outs on the pin. And speaking of which, I'm also going to call something on that view called can show call out. Set that to be true and return this view. And this is how the map view knows what view am I supposed to use to draw a certain annotation. Now, the last thing we need to do, of course, is when we create our map view, we need to pass the annotations we want in. And this has to be an array of MK annotations. Well, airports are MK annotations, so this could be an array of airports, right? So let's do our airports.sorted. Airport is this thing we're fetching all of right here. Got to fetch results. And I'm just taking these fetch results and sorting them. so that we get our annotations. Sorted really doesn't matter. I could also say array of airports. I'm doing this because this takes an array, and airports is a fetched result, again, which is a collection, but not quite an array. So just sorting them turns it into array. I could just say array of airports as well. So let's see if this is working. Hopefully now when we go to our filter, whoa, we see all these airports right here now appear here. We can even see them overseas. And they're really cool, these pins. If you tap on them, it shows you that title and subtitle that we set. Title and subtitle, title and subtitle. Big advancement already right there. The only thing here is when I go and choose Boston, I want this to kind of zoom in on Boston. And also, if I were to click on Houston, Texas here, I want this to change to Houston. So we have a little bit of work to do to hook up this selection up here to whatever selected and zoomed in on in our map right here. So let's start doing the zoom in. How am I going to zoom in on whatever selected here? That's pretty straightforward to do, actually. Remember that every time our SwiftUI update passes happen, we get a chance to update this view. So I'm going to put a little var here called my selection, which is going to be an MK annotation. I'll make it optional because you don't have to select an annotation if you want. But if you do, then when I'm updating, every time I draw, I'm going to zoom in to show this selection. Say here, if I can let annotation equal the selection, so you have chosen one, then I'm going to do this thing in the map view called set region. And set region takes an MK coordinate region. And the MK coordinate region takes a center, which is going to be that annotation's coordinate, right? That's this thing we implemented right here for airport, the CL location coordinate 2D. That's saying where is this annotation? That is the selection right there. And it also takes a span. And this span is an object we're going to create. This is how much to zoom in, essentially. And we can also say that, yes, we want it animated as well. So what is this span? When I zoom in on something, I want it to be kind of a town-sized view. So I'm going to call this span town. It's going to be the span that's approximately a town. So what is a span that's approximately a town? Well, it's an MK coordinate span, and it just specifies the latitude delta, we do 0.1 degrees, and the longitude 0.1. So 0.1 degrees of latitude and longitude is about the size of a town. It's a little smaller than a city, but it's bigger than like a little neighborhood. This is kind of a good size to zoom in on if you're zooming in on some annotation. And this is going to happen every time that this map view gets updated in the SwiftUI reactive UI updating passes. We're going to rezoom to show our selection. So let's go over here and set our selection. Here's where we create our map view. We'll add this extra argument, the selection. And what is the selection? Well, it's just our draft's destination, right? This draft is our flight cert. This is what we're kind of filtering for. And the destination is the destination airport inside draft. It's the exact same thing we're showing as our pickers thing right here. Let's see. All right, filter, hopefully. Yeah, San Francisco. This is San Francisco International. Let's pick something else. How about Boston? Whoop, zooming over. There's Boston. Maybe pick Bob Hope Burbank. Back to Bob Hope. There it is. Now, we can still zoom back out right here and pick other airports. The problem is, though, when we pick them, it's not updating here. So I'm picking this. It's nice. It's telling me it's San Diego International. But when I pick it here, I mean choose this. Go to that place. So how do we make this go both ways? This is working well when we choose Boston. It goes into here and sets the map. But how do we make it work the other way? When we click over here on Newark or whatever, Connecticut airports, it makes that be our destination. Well, how do we do that in views in general, right? If we have a view and we can interact with it and it wants to communicate information back out to some other view, what do? We use a binding. And this map view even though it's UI view representable, it's a view, and so it could have this be a binding. This is now a binding to selection. Now, we will down here go ahead and have our selection be updated and all that, but we have a little bit of problem first, which is that here we are passing our selection as an airport. So this is not a binding to an MK annotation, right? That's what this says, binding to MK annotation. This is an airport. So how do we do that? Can we just do $sign right there? No, we can't, because draft is @state. If draft were an observed object, we could do this. This would work if this were an observed object. But draft is not. Draft is state. And the binding, the $sign of a state, binds to the entire struct. You can't bind it to variables inside the struct. So how the heck are we going to pass a binding to this airport inside of this state? Well, let's create a var that is called destination, and it's going to be of type binding to MK annotation. Now, as soon as I start using MK annotation in here, better go up here and say import mapkit, or code compiler's not going to know what the heck we're doing. So this is a destination binding, and how about we use this binding right here to say pass the destination there. And this, when I compile, is going to work down here. See, we're no longer going to have this thing where it can't infer or any errors down in here, because I am passing a binding to an MK annotation, which is exactly what this thing wants, a binding to an MK annotation. All we need to do, though, is figure out how to implement this var. How do we return a binding to an MK annotation here? We need to somehow make an MK annotation that hooks up to this draft's destination. How are we going to do that? Well, we're just going to use one of bindings constructors. You can see it's got a few here. We can use this one. This is almost kind of a primitive sort of binding, and it just lets you specify a closure to get the value of the binding and a closure to set the value of the binding, which is really getting at the heart of how bindings work, right? Bindings are just getting and setting some other value somewhere else. So it makes total sense that there's a version of binding which is just closure to get and a closure to set. And all we need to do is implement these to get and set the value of the destination in our draft state. Could not be simpler. So let's go do this. It's just a little easier to see what's going on before we do this. Let's do the get first. The get is saying this takes no arguments and returns an MK annotation, of course, because this is a binding to an MK annotation, so we won't be able to get it there. So let's do that. Quite simple here. We're just going to return our draft's destination. Now, this is an airport. An airport is definitely an MK annotation, so this is perfectly legal. Once we put self in here, we can return this value. That super simple. What about on the set side? The set is a closure that takes an MK annotation, an optional MK annotation, doesn't return anything, and just sets the value. Let's have that annotation that it takes be this argument right here. We'd like to say something like self.draft.destination equals that annotation. Woohoo, we're done. Just do the kind of the opposite of this. But this is not going to work. And the reason this doesn't work is that the type of this is MK annotation, optional MK annotation. That's its type. So here we're trying to make an airport equal to an MK annotation. That's not going to work, because an airport is an MK annotation, but not all MK annotations are airports. So you can't just make this assignment right here. And this is where we have to do the typecasting that you read about. And we've talked about briefly a couple of times, maybe in the context of talking about the old Objective-C any type. So I need to cast here. I'm going to say if I can let an airport equal this annotation as an airport. And that is conditionally trying to see if this MK annotation is in fact an airport and not something else that we implement MK annotation on. And if that's true, then I can set my destination to be this airport. So in this way, We are just creating a binding that binds to and from our draft's destination. And we pass that binding right off to our map view right here. So far, our map view is not doing anything to set the selection. It's still just looking at the selection, but let's make sure we haven't broken anything. We shouldn't, because we're still binding to our draft destination. So when we go over here, see, it's still San Francisco. If we change this to Boston, the whole SwiftUI view updating happens, and we get to see Boston. So that's working. But we haven't done anything yet on the other side of the binding, so that when we pick an airport here, it set the selection. So we need to have our map view set the selection. How do we know when a pin has been touched on? In map view, we do that with the delegate. So there's another delegate method here. Map view did select. Where is that? There it is. Map view did select. This delegate method is called whenever one of these pin views is touched on. And this is the pin view that was touched on right here, MK annotation view. That's one. In our case, it's a pin annotation. So we can get the annotation that was clicked on by just asking the annotation view, what annotation do you have? Asking this pin thing, what's your annotation? Now that we have the annotation, we kind of want to do something along the lines of self.selection equals that annotation, except for that self.selection is not here in our coordinator. It's up here in our UI view representable. This is nested class, but it can't see the bars of this outer class right here. So we have to bind this selection from here out to this binding out here. So let's just create another binding right here for our selection. It's an MK annotation. And then when we create our coordinator, let's pass the selection, $selection, which is the $ version of our binding. And we know that dollar of a binding is the binding itself, or a binding to the same thing that the binding binds to. But this doesn't quite work because this is a class, not a struct, so we don't get this free constructor. We have to create our own init selection that takes a binding to an MK annotation, optional. And then again, we can't say self-selection equals selection. This is an @ binding, so we have to say underbar selection. The actual struct is the thing that's passing here. So now our selection binds both ways. When the delegate notices something's been clicked on, it sets it in the selection binding here, which binds to this selection right here, which binds back out to this binding out here, and that's going to set our draft destination. See that in action. Go to our filter. It's binding correctly this way. We got San Francisco right here. Let's go find a different airport. How about Oakland right there? Woo! Look at that. It zoomed in on it and it picked it up here. We can pick it the other way. Let's go Boston. Here's Boston. Zoom out again. Go over here to Newark. Woo! It zooms it again. And if we click done, it has picked this Newark. We get to see Newark Airport. So that is it. That's all I wanted to show you on this view representable side. The next demo we're going to do is view controller representable. But this one really shows you kind of all the things you need to know about binding into a UIKit view, including, if you have to, building your own custom binding with get and set to be able to bind in there. But a lot of times you won't even need a custom binding. You'll have an observed object you can bind to, or you can bind directly to a state or whatever that you can then pass into what's going on here. And you might well have to pass it to the delegate and back like we have here, because the delegate's usually the one handling most of the activity going on in the UIKit view. All right, so that is it for Enroute and the view representable. Let's move over to our other demo, which is an EmojiArt demo. So in this demo, we're going to be wrapping a whole bunch of views, a controller that's controlling a whole bunch of views that we're going to present using a sheet. And this sheet that we're going to present lets you take a picture from the camera or the photo library. We'll start with the photo library here and use that as the background image of our EmojiArt. And then we'll move on to the camera, because there's a couple of things to think about with the camera that are a little different. So where are we going to put the UI that lets us take a picture? and put it as our background. I'm going to drop it right in the up in the navigation bar items. We already have one right there for our pasteboard button on the right. So let's put on the other side, the leading side, some buttons or something that lets us choose this stuff. We'll call this my pick image. And my pick image is just going to be a little var down here. Pick image, some view. We can even make this private, of course. And this pick image, let's make it be an image. System name. How about the image photo? That's a good system image, I think, for picking a photo here. And I'm going to make this larger. Not really sure whether we should be making that larger there, but good for demos. Easy to see what's going on up there. And I'm also going to set the color to be the accent color, the same thing a button would use. And in fact, I could use a button here, but just for variety, let's do an on-tap gesture. This image is going to appear in our UI. Let's take a look at it. Here it is right there. And when I click on this, I want it to bring up this UIKit UI that lets us choose from the photo library in this case. And later we'll add another button for the camera. So how do I make a sheet appear? We know exactly how to do that, right? We just set some sort of Boolean variable. I'm going to call my Boolean variable show image picker equal to true. I need a little private @ state for that. It'll start out as false, of course. And then we're just going to dot sheet is presented and put a binding to that show image picker. And then we're going to have to provide whatever sheet it is that we present. In this case, it's going to be image picker. This is going to be a UI view controller representable that puts up the photo picker. Let's go ahead and do this, file new. Again, it is a SwiftUI view, but since it's a representable, we don't need the var body and all that. I'll call it my image picker. And here it is, as usual, we're doing the integration. We need both SwiftUI and UIKit. And this is just a struct called image picker, which is a UI view controller representable. And it has exactly the same functions as we had in the other one. So let's just type them right in since we already know how to do this. There's the make UI view controller. It has the context. Now, the kind of view controller that we're going to make here is called a UI image picker controller. This is just a MVC, a controller in UIKit that we can use to choose a photo from our photo library or a camera. Let's let picker equal one of these things. I'm going to create one and return it. And we're going to have to configure it a little bit inside here, so we'll leave space for that. Then, of course, we have our update UI view controller. Let's take an image picker controller. Here's where we would update things. I don't actually think we have any updating to do because we just present this view controller and we're going to have a delegate for it, but otherwise it's going to do its thing. We, of course, need make coordinator, and I will do the exact same thing. We'll call it coordinator, and we'll have it be a nested class coordinator. It has to be an NS object because it's going to be the UI image picker controller's delegate. And just for good measure, and I'm not going to explain why, because we're not really that much learning about UI image picker controller, although we are going to learn a lot by doing this. It also has to implement another protocol here called UI navigation controller delegate. This is just a protocol that this image picker requires its delegate to implement. We're not going to use any methods from it, but we still have to put it on there. There are a couple of methods in here, and we really need them both. One is the image picker controller did cancel, and the other is the image picker controller did finish picking media. So let's put them both in here. This cancel one right here is called when the person cancels, of course, the controller. Remember, we're putting up an entire sheet worth of UI here, and it's going to have a cancel button on it. And then this is the one where we actually pick an image, either from the camera or from the photo library. So here's where the action is really happening in our delegate. And this is our picker controller delegate. So let's set our pickers delegate to be our context coordinator, right? We're setting this instance of this that we're going to create. And we'll create that here, coordinator. It doesn't take any arguments as yet anyway. And now we've got it all set up. This is just exactly like we set up the map view. We got the delegate and all that. But one other thing we want to do in configuration here to start is I'm going to set the picker's source type to be photo library. So the picker is going to try and pick an image from the photo library to start. Eventually, again, we'll do the camera, but for now, just the photo library. All right, we go back to our document view up here. We've got our image picker. It should compile now. Let's run to our house. Now, when we tap on this, on tap gesture, hopefully it will put up our nice photo library user interface. And there it is. Woohoo! Okay, there's our photos. Now, if I pick one, like this thing here, nothing happens. If I hit cancel, nothing happens. That's because back here in our pick image over here, we put this sheet up, the image picker up, but we don't do anything when it gets canceled or picked. So of course, this thing never gets put away. This show image picker never gets set to false, and clearly we're not grabbing the image. But we've got this thing presenting, so now let's just do the little bit of work to get this image out of here. Now, how am I going to get that image out of here? One way to do it would be the same way we did the map view. Put an @ binding here and bind to the image, and then the image would be chosen, and we would have to pass it down here to the delegate, and it could set the binding here and it would transport back. That is one way to do it. Just to show you there are other ways to do things, I'm going to do this a little differently. I'm going to add a var here to my representable, which is called handle picked image. And it's going to be a closure. Image return void. And I'm going to call this closure when you pick your image. Now I'm going to give you nil if you canceled or if for some reason I couldn't get the image. And I'm going to give you an image if you actually picked it. Now we know that this handle pick image is actually happening down here. So we have to do the same thing we did with our map, and this is very common to have to do. We're going to have to do the same function down here in our coordinator. Var handle picked image, UI image, void, and pass that to our coordinator. Handle picked image, handle picked image. And again, this is a class, so we don't get this free constructor right here. So we have to say init handle picked image with this UI image that returns a void. Self.handle picked image equals handle picked image. I'm really getting used to typing handle picked image. Of course, we are grabbing onto this and holding onto it, so this is going to have to be an @ escaping. We know that anytime we have a function that we pass in and we hold on to it, we have to let people know that that's what we're doing, that we're grabbing onto it there. Now that we have this handle pick image here, let's just, when we cancel, call our handle picked image with nil, so we know that you canceled. And here I'm going to do my handle picked image with the image. Now, how do I get the image? When image picker controller delegate gets called with this did finish picking media with info, you get this dictionary. And this dictionary has info like how big the image was and what the actual image was. And it's a dictionary that has a bunch of keys. One of the info's keys is .originalImage, and that gives us the original image as a UI image. Of course, this dictionary has any's as the values. This is an old Objective-C API here. So we need to say as UI image and see if we can cast it. And we're doing as question mark. This will return nil if for some reason this is not a UI image. And that's okay, because the handle picked image will have nil, and that'll be just like canceling, no different from canceling. Now, one thing I'm going to do while we're here, I don't think we did this all quarter, which is type aliasing. I had to type this type a whole bunch of times in here. And when you have to kind of a complex type like that, it's not string or some name of a struct, a lot of times we'll create a type alias For example, I might call this thing my picked image handler, and it equals UI image returning void. And then everywhere where I use this, I'm going to put this instead. So here, and here, and here, I'm going to put that. It's kind of good for my API. It's a little more descriptive of what this function was, and it also cleans up things, and I don't have to worry about typing this over and over, and I might make a mistake when I'm doing it, typing it over and over, so like I might forget my question mark or something like that. This prevents that as well. So it's quite common to make type aliases for functions arguments, especially if they're passed around a lot of places. All we have to do now is set this handled pick image when we do our image picker over here. So here's our image picker. Let's do it. The image given back to us here. Now we know that we have to check to see if the image does not equal nil. And if it's not equal nil, then we've got to actually use it as our background. And in any case, though, we're going to set our show image picker to false. We want to dismiss this sheet that we presented. Now, what are we going to do if the image is not nil? This is where we're going to do that kind of bogus thing that I was talking about there, where we're going to throw this thing into the file system, this image into the file system, and grab the URL to it and set that as our background URL. Again, that would tie this whole thing, this document that we're creating, to this device because we're pointing into its own sandbox. Also, by the way, I had to go back in my EmojiArt extension and play a little bit with this image URL. I had to actually check for file URLs because one thing to note is that as you're especially doing your development and running new versions of your app, the application support directory, which is where I decided to put this thing, this image, it changes. The URL for it changes from launch to launch. So here I just have a thing where whenever I see a file URL as our background image, I'm going and re-looking it up in application support to get the new version. So that's a little bit annoying. I think I also had to go over in our document and make sure that whenever I fetch the background image data, I called that image URL again. I was originally only calling it when we set it, but now I'm calling it every time to make sure this file URL gets properly set. So that's just a lot of kind of fratzing around to make this demo go really smooth because I can now type this one line of code right here, which is self.document.background URL equals that image store in the file system. And store in the file system, just this little extension down here that I wrote. You know how to do all this now after the last lecture, getting the directory, appending path component. I use this JPEG data function on UI image to get the data, and then I write to that URL, put it into the file system, and I return the URL that I wrote it to. Really simple. Makes this a one-liner right here. One other thing I'm going to do here, which we haven't talked about this either, I'm a little worried that this closure might be called at an inopportune time. For example, I'm not really allowed to modify myself as a view while I'm in the middle of processing events. You kind of have to wait for everything to settle back down. So to be safe, this closure right here, I'm not going to do this background URL, which I know is going to update my UI. I'm going to do it in a dispatch queue.main.async. Now, why would I be doing this? There's no issue here with multi-threading. None of this is happening on a background thread. This is nothing to do actually with multi-threading. It's just that if I ask my main queue to go do this closure, it's going to put it on its list. And even though I'm running in the main queue right here, it's going to finish doing all the things it's doing here, maybe updating my views. And when it's done, it's going to go to its queue and grab the next one, which hopefully will be mine, and execute it. So it's essentially just saying, do this after everything settles down. And if you start getting warnings when you run that say, oh, you can't update, you're not allowed to modify the view while it's in the middle of constructing its body or whatever, then yeah, you might think of delaying something like this. And we might have wanted to do that in Enroute as well. Okay, in Enroute, when you click the airports in the map, maybe that selection of the airport should have been done this way too, just to be safe. I didn't see it have any problems, but anytime you're having callbacks right here that are happening, especially from UIKit, because UIKit's in a little different world than SwiftUI, There's sometimes a little safety buffer you can put in. And it's not going to hurt anything. We're just essentially doing a user intent here, right? This is an intent to change the background URL. It's perfectly fine to delay that a short moment as we wait for the dispatch queue to settle down and come back around. Let's see if this works. All right, here's our house. Let's see if we can change the background from the house to be something from our photo library. Let's click on the photo library. Here it is. Now let's go pick this nice little green. Woohoo, it worked. We can zoom in and out and everything. And we could even make sure that it's really saving things here. Let's go back, run again. House. It's still in there. I'm zoomed in. All right. So this is great. This is working for the photo library. Very simple, very powerful. It looks really nice in our code here. Our SwiftUI code is all SwiftUI-ish. There's really not a lot of weird stuff here. And even the image picker, pretty straightforward. This is pretty much a minimal amount of code to get a UI image picker working. Now, what about the camera? Making this UI image picker controller pick for the camera, it's really simple. It's actually just changing this photo library right here to be .camera. However, I really want to use all this code for both the photo library and the camera. So let's make this be a var here. So we'll say source type and make this into a var here. And this type of this enum is UI image picker controller dot source type. That's the type of this enum essentially. And we just instantly made it so that this image picker can either pick from the camera or from the photo library. And back here, of course, now we have an error. We need to provide the source type. Let's create a little image picker source type @state. And we'll set it equal to UI image picker controller source type photo library. It doesn't matter what we choose here, because what we're going to do is we're going to have this photo one set this self image picker source type equal to the photo library. And then we're going to have a whole other button right next to it, camera. And it's going to have its source type be the camera. We'll put these two things in an H stack, so they'll be sitting side by side in that upper left corner up there. And that's all we should have to do, right? Let's take a look. All right, here's our house. There, we got them there. So let's see if the photo library, it still seems to be working. You can choose different images, works great. How about the camera? Whoa, our app crashed. What is going on here? Let's look in the console. Of course, you know, every time your app crashes, you want to go look in the console, see what happened. And sure enough, here it is. Source type 1 not available. Oh, yeah. And the simulator doesn't have a camera, so it crashes our app. So the camera, UI image picker controller, if you look at this documentation, it's very, very clear about the fact that you should not ask for this source type camera unless you've checked first to make sure there is a camera. So we'll just do that here. If UI image picker controller dot is source type available, and we're talking about the camera here, then we'll put this camera here. Now when we run on our simulator, no camera. Woo, it worked great. Okay, but we want to see the camera in action, don't we? So let's try running it on a device. I have a device attached here, a gold iPad. Let's run it on that, see what happens. All right, we got a couple of documents here. Let's go to our barn document, and let's bring up the camera. See the little camera picture there? Bring that up. Oh no, it crashed again. What? Look back here. Oh no. And what does it say? It says, this app's Info.plist must contain NS camera usage with a key with a string value explaining to the user how the app uses this data. That's right. We can't just go willy-nilly choosing people's cameras and microphones and other things on their device. We need to ask for permission. And part of asking permission is explaining why you want to use this thing. So it's saying here, go to the Info.plist and add this. Let's do exactly that, Info.plist. The way we add an entry to the Info.plist is we right-click and say Add Row. There it is. And then we just scroll down. This is a privacy thing, so it's going to be down under privacy somewhere. Here it is, privacy, oh, the camera. See there, privacy, camera, a lot of privacy things here. Camera is the one we want, and we're just going to explain why we want the camera, why we want to use the camera, and we're going to say, EmojiArt lets you set the background of your documents using the camera. That's our explanation as to why EmojiArt wants their camera right there. Okay, let's try it again now. Okay, we'll go to Barn again, hit the camera. Now notice it's asking us, do you want to allow the user to use the camera? And it's got our little explanation in there. That's great. So we'll say allow, and then let's go take a picture here, and maybe that, yeah. And we'll say, yeah, we want to use this photo. Woohoo! It's our background image. So the camera was really just as easy to do as to forward to the library. We just had to make sure the camera is actually available on a device and then provide that little info to the user about why we want to use it. So that is it for our UI view controller representable demo. Now you know how to put both views and view controllers into your app. And that's all I have for you this quarter. So now it's your turn to go show us all that you've learned with your awesome final project. I look forward to helping you down the stretch with any questions you have about that. And thanks for listening to all these lectures, and good luck with your final project.
For more, please visit us at stanford.edu.